In the figure above, the shaded rectangle is similar to the outer rectangle. The length of the outer rectangle is 4 feet, as we see in the diagram, and the perimeter of the outer rectangle is 14 feet. If the width of the shaded rectangle is 2 feet, which we see up here, what is the area of the shaded rectangle? To find the area of a rectangle, we just need to know its length and its width and multiply them together. We actually already know the width of this rectangle. It's 2 feet. So let's find the length of the shaded rectangle. Before I go about doing that, let's think about the area is going to be achieved by multiplying these two values together. This L that I just wrote here, I think that has to be less than 4 feet because this rectangle is clearly smaller. It's completely contained within the larger rectangle. There's no way it's going to have a larger length. So its length will have to be less than 4, meaning the area would have to be less than 8. I see a couple of answer choices that are way too high. So now, even if we were to blindly guess, we just doubled our chances of getting it right. So let's move on and figure out what little l is. We're going to use this piece of information here that the shaded rectangle is similar to the outer rectangle. And yeah, they're alike in many ways, but they're similar in more than just this vague general sense. The word similar in the math world has a very specific meaning, and it means that their side lengths are proportional to each other. So what I mean by that is, well, I'm calling this side little w and this side little l, so I'll call this side big W and this side big L. So what I mean by proportional is big W over big L would be equivalent to little w over little l. There are actually many equivalent ratios that you could have written, so if you have something that looks slightly different, that doesn't necessarily mean it was wrong. One alternate of many would be something like big W over little w equals big L over little l. But I'm choosing this one. So let's fill it with as much information as we have so far. We know that little w is 2 feet long. And we also happen to know that big L is 4 feet long. And that's because we wrote big L right on this 4-foot side length. So we want to get little l so that we could find the area of the shaded rectangle. We'll have to find big W first. So let's use this information that the perimeter of the outer rectangle is 14. And let's think about what makes up that perimeter. We have 2 side lengths of big W and 2 side lengths of 4 feet. So these 2 with length big W would be a 2 big W, and the 2 that make up, the 2 that are 4 feet long apiece would make up 8 feet altogether. So 2 times big W plus 8 equals 14. Subtracting 8 from both sides gives us 2 big W equals 6, and dividing by 2 gives us big W equals 3. So I'll fill that in. And now we have enough information to solve for little l using our ratio. So let's do that. Big W over big L, that would be 3 over 4, and that's equal to little w over little l. Little w is 2, and we're solving for little l. At this point, we have fraction equals fraction, so why don't we cross multiply? And we would have 3 times little l equals 4 times 2, and that's 8. Dividing by 3 gives us little l equals 8/3. So okay, we're almost there. We got 8/3 for little l. Now we just have to plug this into the area formula and get our final answer. So the area is length times width. Little l was 8 over 3. Little w was 2, and I'll call that 2 over 1. So multiplying the tops gives us 16. The bottom would be 3. And this looks like it's going to be answer choice E because it's not an integer, but let's just check. 3 goes into 16 5 times. That would be 15. So there's 1 left over. So that's 5 1/3 square feet. And finally, our marathon geometry problem is complete.